இது கனெக்ட் பண்ணு. Guys, those who are online, are you able to hear me?
Yes, sir.
Okay. Is this right? So what was the last topic we saw? Last topic. So we were discussing a problem, right? That is based on what will happen when the dielectric. So you get C dash is equal to epsilon naught is something by B minus T1 is T1 by K1 minus T2. Remember this? Plus T2 by K2 minus something so on, right? So this is the value of the new capacitance that we get formed. So apart from this, there is only one subtopic that is left out. That is energy stored in a capacitor. Okay. So write down the heading as energy stored in a capacitor. Energy stored in a capacitor. We are talking about the parallel plate capacitor. See, if I take two plates, right, and then I keep charging this. Right, you understand? I keep charging this, then what is going to happen? The charges will get obviously deposited on the plates of the capacitor. Is that right? Right. So when you connect it across a potential source of heat, right? Now let's say at some instant t, let the charge on capacitor be q, small q. Okay, means what is happening? See, when you connected the potential source, the charge is not directly going and completely sitting. It starts at some zero and slowly it increases to a certain value, right? So during that process, let's say it is taking few milliseconds for this process to get complete. But there will be some instant time t at which the charge is not complete. It is neither a zero value nor a complete value. So in the next dt instant. Okay, let the charge on the capacitor be dq. Okay, so in the next dt seconds, the charge on the capacitor that is getting the charge on the capacitor getting deposited is, let us say it is dq. Okay, then what is the small amount of work done? What is the small amount of work that is done? That is dw is equal to q into, or I can write v into dq. Observe what formula I applied. Work done is equal to q into v. But why did I write dq? Because small amount of charge is getting deposited in the time dt. So this dq multiplied with the potential source across which you connected is going to get you dw. Right? Now, for this, can I write something like this? dw is equal to, how can I write v in terms of q and c? V is equal to how much? You know this formula, right? C is equal to q by v, which implies v is equal to q by c. So it is going to be q divided by c into dq. Better. So dw is equal to q by c into dq. Now, then what is going to be the value of w? Integral of q by c into dq. So q will 1 by c will come out. 1 by c into integral of dq by q. And let's say the initial charge on the plates of the capacitor is 0, and the final charge is capital Q, where capital Q is the maximum charge that can sit on the plates of the capacitor. Oh, sorry. It's Q dq. It's Q into dq, where the initial charge is 0. That is before you connected the potential source, it was 0, and the final value is capital Q. Are you able to understand? So this will be equal to 1 divided by c into, what is q dq, guys? So integral of q dq is q square by 2. And if you apply the limit 0 to capital Q, it will become capital Q square divided by 2c. So this is going to be the amount of work that is done on the plates of the capacitor in the process of charging. Okay, and this work done will get stored in the form of the electrostatic potential energy in the plates of the capacitor. You able to understand? Is that clear, guys? So make a note of this derivation.
Sir. Sir.
Those who are online, you're able
What
to
have you written after getting?
After? After getting, I've written at some instant t.
No, sir. In the last second, let the charge on the capacitor.
Let the charge on the capacitor during. So the charge on the capacitor getting deposited is dq.
Okay, sir.
Now are you able to see? Now is it better?
Yes, sir.
Yeah, a little bit of lighting is there, but is it better now?
Yes, sir. It is better.
Yeah. Right. So then it is q square divided by 2c, but you know that q is equal to cv, right? So if q is equal to cv is substituted, then what will happen to the energy? It become uh, c square v square divided by 2c. So c and c will get cancelled. We get half cv square. This is another formula. This is the most commonly used one. Okay, it is half cv square. Similarly, you know that v is equal to q by c. Right? So from this I can write v is equal to q by c. So you know that u is equal to q square by 2c. Sorry, u is equal to half cv square. So half into c into, in the place of v, I can substitute the same. Sorry, what did I write there? Sorry. So q is equal to, so we can write c is equal to q by v. You're able to understand. So c is equal to q by v means, you know that u is equal to half into cv square. This will become half into c further what can I write? Q by v into, you already have a v square. So v and v will get cancelled. You have q into v divided by 2. Okay. So these are the three formulas that you need to know. Q square by 2c. Okay. Half cv square and q into v divided by 2. Take time. Is that clear, guys? Right. Can I rub this side? See, one last value is energy density of a capacitor. Energy density of a capacitor. Okay. So energy density is something like this. Energy density, I can write it as energy stored per unit volume. Okay. Energy stored per unit volume is what is energy density. Okay. So what is the value of energy stored here? It is half cv square. I'm using this expression. Half cv square divided by what is going to be the volume of the capacitor. So can I write volume of the capacitor as area multiplied with distance, where this is like a plate, right? So it has a cross-sectional area multiplied with the distance of separation between them is going to give me the volume that is occupied by this capacitor. Correct? So half into what are the capacitance of a parallel plate capacitor? So I can write energy density of a parallel plate capacitor. Add this word, okay? Energy density of a parallel plate capacitor. So half into the base of C, I can write it as epsilon naught A divided by D. Correct? Into B square. In the place of B, what is the relation between B, E, and D? What is the relation between B, E, and D? So we know that electric field is equal to V divided by D for a capacitor. So V will be equal to E into D. So it will be E into D, the whole divided by area is A only. Distance, I can call it as D. And remember, this is D square. Any doubt, guys? Is it clear? Right. So this will become half into epsilon naught A divided by this D will get multiplied with this D and it becomes D square into this becomes E square D square. So D square and D square are gone, A and A are gone, and this value will be half epsilon naught E square. Okay. Half into epsilon naught E square is what is the energy density of a parallel plate capacitor. Make a note of this.
Sir, what have you written before distance
Sorry, no?
of CV square divided by
Where half CV square divided by area into distance. This one only, no?
yes, sir.
Yeah, that is area into distance. So area I wrote it as A only, and distance I wrote it as D. Okay. Here is. So with this chapter is over. Okay. So now we'll do some problems that are based on the topics. Okay. So all of you take out your NCRT. So NCRT, go to the exercise problems. So 2.1 we are done, right? We'll do 2.2. So what does 2.2 tell us? There are, read the question. A regular hexagon of side 10 centimeter has a charge of 5 microcoulomb at each of its vertices, right? Calculate the potential at the center of the hexagon. So if you take a hexagon, so Q, right? So there is a charge that is placed at the center. Sorry, there is no charge at the center. There is a point at the center, and we need to find the potential due to all these charges put together at point P. Right? How do we do that? Say this is 10 centimeters. So what is the angle between these? 120. So it is 120 degrees, right? Now if I join to this point and this point, this angle will become 60. This will also be 60, except it. Then how much is this angle? 60. So if this is 10 centimeter, this is also 10 centimeter, this is also 10 centimeter. So the total potential at point P, can I write it as Vp is equal to V1 plus V2 plus so on till Vn or V6. So there are 6 charges, but V1, V2, V3 till V6, everything is the same. So can I write this as 6 times V1? How did I say they are same? Because same magnitude, same distance. So what are the formula guys? 6 into KQ divided by R. So 6 into 9 into 10 power 9 into what is the value of Q? Q only, right? Value given up. How much is it? 5 micro. So 5 into 10 power minus 6 into divided by what is the distance now? 10 centimeters. So 10 into 10 power minus 2 meter. Right? This 5 will cancel this 2 times. This is going to happen. It cut 3 times. So 9 into 3 is 27 into 10 power 3 divided by 10 power minus 2. So how much is answer going to be? Volt. So it is 27 into 10 power 5 volt. Clear? What about the next problem? Guys, those who are there online are able to understand? Shall I proceed to the next one?
Yes.
Yes.
Sir, how is dW equal to VdQ? Because Nitish, did you get the answer for that? Yeah. So let's do 2.3. What about 2.3 guys? Tell me. So how to do 2.3? Two charges, 2 microcoulomb and minus 2 microcoulomb are placed at point A and B, 6 centimeter apart. Identify the equipotential surface of the system. So what did they say? There is 2 microcoulomb charge and minus 2 microcoulomb charge, which are placed at a distance of how much value? 6 centimeter, right? Okay. Now your job is to find the equipotential surface for it. So go refer the notes, or you can refer the textbook. Or how will the equipotential surface? Page number 60. So page number 60. How will the equipotential surface look for two unlike charges? We'll have set of concentric circles. Right, page number 60 in your textbook. So you're able to see, right? Diagram A at the bottom, 2.11 A diagram at the bottom. Right. So that is the equipotential surface. Now, what about the next question? Okay. So, what is the direction of electric field at every point on this surface? Which surface are they trying to talk about? On the equipotential surface. What is the direction between them? Direction. Direction of not direction of electric field with respect to a system of positive and negative charge. That's not what they're asking. Read the question carefully. What is the direction of electric field? Away, okay. The direction of electric field. Somebody told the answer. It is perpendicular. Because I told you one important point. What is it? Electric field with respect to an equipotential surface is always perpendicular. So that is what they are expecting. So you need to write the answer as perpendicular to this equipotential. That is the keyword. So for A, you refer textbook. right? And the answer for B is perpendicular to the surface at every point. Okay, next. What about the next one? 2.4. So read the question. What are they saying? 2.4, tell me. They read the question. A spherical
conductor of radius 12 centimeter.
Okay, there is a spherical conductor of radius 12 centimeter has a charge
1.10 power minus 7.
So charge on it is 1.68 to 10 power minus 7. Minus 7 coulomb.
Distributed uniformly on its surface. What is the electric field inside the sphere?
Okay. So it is distributed uniformly. Read the question carefully. Distributed uniformly on the surface. If that is the scenario, what is the electric field here? Answer. This is reason. Electric field. What is the first keyword they gave? Spherical conductor. Right. So for a conductor, electric field inside is 0. Then what is the next part of it? Outside. So for outside, we already know the formula from previous chapter. Electric field is equal to 1 divided by 4 pi epsilon naught, capital Q divided by small r square. What is the distance from the center they have given? Radius, outside, what distance? Just outside. Just outside means you can take it on the surface itself. So Q is how much? 1.6 into 10 power minus 7. 1 by 4 pi epsilon naught is 9 into 10 power 9 divided by r square is 12 into 10 power minus 2 the whole square. All this will get the answer. Okay. These many Newton per coulomb, or you can write volt per meter. Both are same. Is it clear? Those who are online, is it clear?
Yes, sir.
Okay. We go to the next one. Yeah. 0.4. So those are completed. You can try solving the next one. Point. Try to read and solve. One more subdivision. What is it?
18 centimeter away.
18 centimeter away. Replace capital R with smaller. I hope you can do that, right? So what is the formula? E is, so electric field, if you recollect, 0 Q by 4 pi epsilon naught capital R square and Q by epsilon naught 4 pi, sorry, Q by 4 pi epsilon naught small r square. In the third case, use small r as 18, you will get the answer 18 into 10 power minus 2. Okay. So we'll proceed to the next one. Tell me. 2.5.
Parallel plate capacitor. With that between the plates has a capacitance 8 here. What will be the capacitance?
8 P F 1 minute. I'll make note of data. So there is a parallel plate capacitor, and between the plates of the capacitor, what you have? You have air medium, right? It is filled with air. The capacitance of this is
8 P.
8 P F. PF is picofarad. So 8 into 10 power minus 12 farad. Correct? Pico. Right. Next.
What will be the capacitance? The distance between the plate is reduced by half, and the space between them is filled with the substance of dielectric constant.
Okay, it's a good question. So C is equal to, you know that epsilon naught A divided by D. This is the initial case. So I generally solve it according to the case what they have given. In the second scenario, what are they doing? The distance between the plates is increased or decreased by half. Okay, the distance between the plates is decreased by half. And what have they done? They have filled it completely with the completely the water. It's completely filled up. Read the question. What is the last part? Where the distance between them is decreased by half, then
Space between
Space between them, it is completely filled with the dielectric material of how much value? 6. So K is equal to 6. Okay. See, generally, if you observe the formula itself, you can tell me one thing. If the distance is decreased, what will happen to the capacitance? Increase. So if dielectric is inserted, again it is going to increase. So D by 2 and the dielectric both are contributing to the factor of increase in the value of capacitance. They are asking by what factor will it increase. Okay. So for that, can I write in the second scenario, C dash is equal to, can I write it as K times epsilon naught into A divided by D by 2. Simple. Epsilon is replaced with K times epsilon naught. You understood why? Yeah. Generally, you write it as epsilon naught, epsilon A divided by D. But K is what is the formula? Epsilon divided by epsilon naught. Take it to the other side, then epsilon will be equal to K times epsilon naught. So K times epsilon naught into A divided by the distance between them will increase by a factor of 2. So 2 times K into epsilon naught A divided by D, accepted. Right? But what is this epsilon naught A divided by D? That is what is 8 into 10 power minus. Correct? So it becomes 2 into 6 into 8 picofarad. So how much will it be? 12 into 8 is 96. So 96 picofarad is going to be the answer. Means it has increased by a factor of 12 times. It is increased by a factor of 12 actually. Is that clear? So this is a good problem. Clear, guys? Those are online clear?
Clear, sir.
Okay. We can work on it. Try the next one. What are they mentioning? 0.66. Go ahead. Explain combinations. Oh, I missed it. Okay, write down the next statement. Sorry, chapter is not yet over. This is the last talk. So write down the heading as combination of capacitance. So when I say combination, what are the two combinations we've been talking about? Actually, three. Series, parallel, and the third one will be mix. Right? It will be a combination of both. Right? Now, first we will take series. So heading will be capacitors in series. Okay. So when can you say the capacitors are connected in series? Okay. Let's say there are three capacitors of values C1, C2, and C3. Okay. There are three values C1, C2, and C3, and the potential difference applied across the combination is V. Okay. So you have this formula Q is equal to C into V. Right. Whatever you do, right, you can't change the capacitance value. It's always a constant. So depending on whether Q is a constant or V is a constant, the combination is basically classified into series or parallel. So in a series combination, what do you think will be common? It is the charge. Because wherever you see voltage is constant, is always parallel. Same is the case with resistors, right? So if all the three capacitors in this combination, if all the capacitors have the same magnitude of charge present on them, then you can say that all these capacitors are connected in series. But what will get divided? Voltage. So here if I say the potential difference is V1, here I say V2 and here I say V3, then I can say V1 plus V2 plus V3 will always be equal to the total potential that we have supplied. That is V itself. Are you able to understand? Right. So what is the value of V1 next? What is the relation between V, Q and C? Q is equal to
Q by C.
Yeah. So I can call it as Q divided by C1. Be careful, don't write it as Q1 by C1. It is Q by C1 plus Q by C2 plus Q by C3. This will be equal to what will be the equivalent circuit for it? What do we mean by equivalent? Equivalent means you replace all these devices with one device. Let's say you have 100 capacitors in series. You will replace all those 100 with one capacitor, which will do the same work done by the combination. Correct? So can I call the equivalent capacitance as CS? And you need to ensure that you are connecting it across the same potential source. If this is CS, what will be the charge on this capacitor? It will be the same Q, right? So here can I write it as Q divided by CS? So what will get cancelled? Q itself is lost. So 1 by C1 plus 1 by C2 plus 1 by C3 will be equal to 1 by CS. So this is something similar to what has happened in resistors in parallel. So capacitors in series is a similar scenario of resistors in parallel. Okay, is it clear? Done? Right. It's nothing. Okay. Here is now similarly, if I want capacitors in parallel, so if I take the capacitors in parallel, it says capacitance C1, C2, and C3. The potential here will be V, and the potential here will be same V. Here also will be same V. But what about the charges? Q1, here it will be Q2, here it will be Q3. Accepted? Right. Such that the total charge supplied by the battery supplied by the battery, if I call it as Q, then Q will be equal to Q1 plus Q2 plus Q3. So what is the value of Q, guys? So Q from here, what will it be? Q is equal to Cp into Vp. So Cp is the equivalent capacitance in parallel into V. What is Q1? C1V, C2V, C3V. Then what is going to happen to V? Cancel. Then Cp will be equal to C1 plus C2 plus C3. So when capacitors are connected in series, so in parallel, their individual capacitances get added. Okay. So these ones obviously you have to solve based on problem. Having this knowledge, we will try to solve some problems. So let's take an example problem, I think. Example 2.9, page 79. Example 2.9, page 79. Okay. So there are 4 capacitors given. So how are those capacitors connected? We don't. Correct? This is 500 volt. Correct? Wait a So how much is it? How much is each capacitance?
10 micro.
So everything is same. So can I write it as C, C and C? Right. Correct? What is the question? So let me read this. There is a network of 4 10 microfarad capacitors which are connected to a 500 volt supply. Determine the equivalent capacitance of the network. That is the first question. Second, the charge on each capacitor. So that's what we need to find. So what is going to be the equivalent capacitance? So for the sake of equivalent capacitance, what we will do is we label them as C1, C2, C3 and C4. For equivalent capacitance, can I say C1, C2 and C4 are in series? Right? So what is CS here? So for us to find for CS, I need to find 1 by CS is equal to 1 by C1 plus 1 by C2 plus 1 by C3. So what is 1 by? So everything is the same. It will be 3 by 10. Correct? That is 1 by CS. So CS will be equal to 10 by 3 microfarad. Accepted? Correct? So these 3 can be replaced with a 10 by 3 microfarad capacitor. Now this is equivalent to whom? This is equivalent to a circuit like this. This is 10 by 3 microfarad and this is going to be 10 microfarad and this is going to be 500 volt. Now 10 by 3 and 10. If I call this as CS and this as C3, CS and C3 are in? Right. So CS and C3 are in parallel. So if CS and C3 are in parallel, then what can I write the equivalent capacitance? CP will be equal to CS plus C3. What is CS next? 10 by 3 plus. So how much will be the answer? So 40 by 3 microfarad is going to be the equivalent capacitance of this network. Correct? Then the next part of the question is they're asking what is the charge on each capacitor. Okay, for that we will solve. First copy this. So it's 40 by 3 microfarad. Okay. Any doubt? Those who are online, any doubt? Sir, how is D equal to V? I'll tell you. Nitish, I'll tell you. Apart from that, guys, any other doubt in this problem? Okay. Now listen. So how to find the charge on each capacitor? So to find charge on each capacitor, first what we will do is we'll draw the equivalent circuit. So what is the equivalent circuit of this? This is going to be 40 by 3 microfarad connected across 500 volt supply. Correct? Now, what is going to be the total charge supplied by the battery? So Q total is how much? So C equivalent into V. So what is the value of C equivalent? 40 by 3 into, I'll leave it as microfarad into 500. Okay, microfarad I convert to 10 per minute because coulomb you don't write it in microcoulomb, write it in millicoulomb. Farad into 500. How much will you get? 20,000 into 10 power minus 6 divided by 3 coulomb, right? So can I write this as 2 by 3 or 20 millicoulomb? Sorry, 20 by 3 millicoulomb. Can I write it like correct? So this is the total charge supplied by the battery. But what is the question? Find the charge on each capacitor. Okay. Tell me one thing. Out of the 20 by 3 charge that is there, where is the charge getting divided? So one out of 20 by 3, some part will go to C3 and the remaining will go to C1, C2 and C4. Now the question is, among C1, C2 and C4, will it get divided by 3 or will it be the same value? It will be same value because they are connected in series. Okay. So what we can do is, since we know the total charge that is supplied by the battery, let's try to find out what is the charge that is present on C3. So what is the charge present on C3? That is Q3 is equal to how much? Can I write it as C3 into V? C3 is how much? 10. So 10 into 10 power minus 6. into V is 500. So if you try to calculate this, you should get the value as 5 millicoulomb. Accepted? So if you calculate it, you will get the answer as 5 millicoulomb. So out of the 20 by 3 millicoulomb, that is 6 point something. Out of the 20 by 3 millicoulomb, 5 is going to C3 and remaining will go to C1, C2 and C4. So Q1, Q2 and Q4 is equal to how much, guys?
20 by 3 minus
Is equal to 20 by 3 minus 5. That is going to be 15 by 3. 15 by 5 by 3. 5 by 3 millicoulomb. Correct? So that's the answer. Right. So now we'll solve the 2.6 or something from the exercise. You told it's based on series and parallel. No? 2.67. Yes. Okay. So going back to exercise 2.6. What is the page number? 86. 86. Sir.
the capacitor C4
Okay. So 3 capacitors each of how much value? 9 picofarad are connected in series. Okay. What are the equivalent capacitance? Answer is 3. How do we calculate it? 1 by CS is equal to 1 by C1 plus 1 by C2 plus 1 by C3. Right? All the 3 are of same value. So it becomes 3 by C. That is 1 by CS. So CS will be equal to 9 by 3. That will be 3 picofarad. So generally when equal values are connected in parallel, right, it gets divided by the numbers which are connected, so not parallel series. When equal values of capacitors are connected in series, then the equivalent will be that value divided by n. What about 2.7? So 2.6 is it? What is the other question?
What is the potential difference across each capacitor if the combination is connected to 120 volts?
So you have 9, 9 and 9. They are connected across a 120 volt supply. What are the potential difference across each? How to find? So what will be the answer? So Q is constant, correct? How much will Q be? So Q total will be equal to C equivalent into V. What is the value of C equivalent? So 3 into 10 power minus 12 into what is the value of V? Or I leave it as P itself because in the next step we get cancelled. 3 into 120. So how much is it? 360 pico coulomb. Okay. Now you need the potential here. So V1 will be equal to Q by C1. So Q is how much? 360 divided by 9. So answer will be 40 volts. So actually, we not even solve it. I can tell it directly because all the three are identical. So 120 we get divided into three equal parts: 40, 40, and 40. Okay, now this is what. Next to the 1 by C equal. So formula will go until Cn. 1 by Cn very good. Okay. Then we do the next one. 2.7. Pixel. No, 2.7. I think you guys can do that. Do it fast. So there are three capacitors, each of value how much? 2, 3, and 4 picofarad are connected in parallel. What are the total capacitors? 2, 3, and 4 are connected in parallel. Equivalent capacitance is 9 picofarad. Then what are they asking? Determine the charge on each capacitor if the combination is connected to a 100 volt supply. How much will be the value? So if the combination is connected to a 100 volt battery, what will be the charge on each? So 2, 3, and 4. All the three are connected in parallel, and the combination is connected across 100 volt. Correct? Is this what they are trying to say? So 2 picofarad is 3 picofarad and 4 picofarad. Correct? Now the question is 100 volt is there. Then how much is going to be the charge here? Q1 will be equal to C1 into V. So C1 is how much? 2 into 10 power minus 12 into V is 100. So it will be 2 into 10 power minus 10 or 0.2 nanocoulomb. Or you can name it as 2 into 10 power minus 10 coulomb itself. Nano is 10 power minus 9. So what about this one? 0.3 nanocoulomb, 0.4 nanocoulomb. Then you can do it. Correct? Remaining problems we'll do tomorrow. So apart from this, any other doubt? Any doubt from the previous chapter? Any concepts being taught? Any doubt? Clear? Okay. Guys, those who are online, everything is clear?
Yes, sir.
What is the value of? What is C naught? Epsilon naught A by D, that's it. C naught doesn't have any fixed value. It depends on the dimension. Generally, you write it for air only. Wherever you put a circle, right, that is for air. Air or vacuum. Nitish, you were asking something 1 minute. Sir, how is dW equal to VdQ? See, it is very simple. You know the formula U is equal to Q into V, right? So instead of U, I wrote it as dW. Instead of Q, I wrote it as dQ. Into V is V only. That is the formula that we used. Okay. Yeah. But, so if there is no doubt, we can wind up this. Those are online, no doubt, no?
Yes, okay, yes.
Okay, we'll wind up.
Thank you, sir.